Bismillahirrahmanirrahim. Today's topic of discussion is polarization of light. What is polarization of light? The restriction of light to a single plane of vibration is called polarization of light, or we can define as the confinement of beam of light to a single plane of vibration, or the process by which the electric and magnetic vibration of waves are restricted to a single plane of vibration is called polarization. As you studied in the previous topics, like interference of light and diffraction effect, which shows the wave nature of light, that explain the wave nature of light. That light is a wave, not a particle. But still, we are not clear about whether light waves are longitudinal waves or transverse waves. Keep it in mind that polarization is the property exhibited by the transverse waves only, not the longitudinal waves. So, summarizingly speaking, the polarization of light it is particularly used to explain us the whether the type of waves are longitudinal or transverse. A simple experiment which with the transverse waves. To study that only transverse waves exhibit polarization property, for the purpose to explain, consider a string and whose one end is free and another end is fixed with a support. We have a slot. It is represented by SRP as mentioned here. This is a slot. When the slot is placed parallel to the vibration of the string, so the transverse waves generated in the string will pass through it without any disturbance and reach to the from one end to the another end. If another slot is placed at right angle perpendicular to the same vibration, this is slot placed perpendicular to the vibration of the string. So what will happen? Then no wave will pass through the slot. We can see here, no wave we can see here. Now, if the string is replaced by the spring or slinky, and the compressional waves generated in it, so these compressional waves will pass through the slit, irrespective or regardless of the orientation of the slot. Now, the next thing, that is the polarization by reflection. Generally, polarization of light wave can be obtained by different ways. That is, by using polarized, by using the reflection, etc. Here in our accelerated syllabus, we are dealing with the polarization applied by reflection. Here we can see here two types of medium we have. One is rare medium or air, and another one is denser medium or glass or water we can use. When unpolarized light or ordinary light that incident or fall from the rare medium on the denser medium, so the reflected rays or the reflected light may be completely polarized or partially polarized or unpolarized. It's depend upon the angle of polarization. What is its incident angle? Suppose that unpolarized light beam incident on the denser surface, as I mentioned. Each individual electric field vector can be resolved into two components. We can see here two things on the ray of light. One is dot, that is along the surface of vibration or along the propagation, and another one that's are arrows that are perpendicular. So these are actually the resolution of a vector field into components. One is parallel to the surface represented by dots, and another one that is perpendicular to both the surface as well as to the propagation represented by arrows. Now, it's found that parallel beam reflects more strongly than the perpendicular components. This results in polarized reflected beam, and the refracted light beam is partially polarized, as mentioned here. We can see here, according to the first part, that is, we can obtain here, we can get here or observe here the totally polarized reflected light that is concerned to the first point, dots, and another we can see here the partially plane polarized refracted rays that is in connection with the second point that is perpendicular to the both surface and direction of propagation. Now, we can explain this thing by using the Brewster law and Brewster angle. The Brewster angle, or polarizing angle. It is actually the angle of incidence on a transparent medium, glass or water, at which the reflected and refracted light waves are completely plane polarized. As mentioned here, angle of incident, for which we can obtain the totally polarized reflected and partially plane polarized refracted light. Keep it in mind that at such angle the reflected rays and the refracted rays are mutually perpendicular. This is a particular angle. For each and every angle we cannot obtain the polarized light. Sometimes we will at different angle we can obtain completely polarized, partially polarized, or unpolarized light. So, applying Snell's law, we can write as sine angle of incidence by sine angle of refraction that is equal to refractive index. Here we can see here, and one sine angle of polarization is equal to n2 into sine angle of refraction, where n1 and n2, these are refractive indices of the medium. 1 and 2, one is rare medium and another one is denser medium. From the figure, to find out the value of the angle of refraction, that is, we can see here, this is IP plus this is IP plus 90 degree plus angle of refraction. So this is totally equal to, this angle is equal to this angle, this plus this 90 degree plus this angle R, that is equal to, totally equal to 180. Its total value of angle is equal to 180. So we can write as our angle of refraction is equal to 90 degree minus 180 minus 90 is equal to 90 minus IP. Putting in the equation A, we have, that is N1 sine IP is equal to N2 sine, instead of R we will use 90 minus IP. From mathematics we can see here, sine 90 minus IP is equal to sine 90 degree cos IP minus sine IP into cos 90. Cos 90 is equal to 0 and sine 90 is equal to 1. So this is equal to cos IP. Therefore, using the equation will become as N1 sine IP is equal to N2 cos IP. So rearranging the equation, we can see here sine angle IP by cos IP is equal to N2 by N1, that is equal to tangent IP divided is equal to N2 by N1. N2 by N1 is actually the ratio of the refractive indices of the media. IP is equal to tan inverse N2 by N1. This is non-Brewster law for the glass, and its value is equal to, for the refractive index value is equal to 1.55, so the value of IP is equal to 57 degree. So the Brewster law can be defined as, it's actually the relation between two things, that is angle of the polarization and the relation between the refractive index and the angle of the polarization. Thanks to all.